All right, the last topic in this module, in the last lecture for this module, is on debugging. We've already encountered a little bit of debugging already because the old urban legend is that the old early computers, ENIAC, being one of the earlier ones, were huge things. And you didn't sit down and type and program them. What happened is if you wanted to do something, you literally had to crawl inside it and move wires around. The memory was big relays that were switches, like real switches that opened and closed. And the rumor is, or the legend is, that one time when they were trying to figure out what was wrong with the program, when crawling around in it, they found a moth that had been squished in some of those relays, and hence it's been called bugging ever since. But basically it means your program won't run. And they come in sort of two different varieties. There are syntax, and that happens with modern editors like we're using in MATLAB. A lot of times as you're typing, it'll catch your error. But the syntax means you used the wrong word, you haven't spelt it right. There's something wrong with the form of your program. And so those are syntax errors. Those are usually the easy ones to catch. The hard ones to catch, what makes programming, debugging more of an art form than a science, is the ones when you run it, and sometimes it'll cause the computer to do something it can't do. And so it'll give you an error message, a runtime error message, and you have to take those with a grain of salt. If they guessed at what you might have done wrong in both syntax and those type of error messages. So they usually point you at the right place, not even all the time, and you go from there. But the harder ones are when it runs and gives an answer, but the answer's wrong. And you know that it's wrong, but you have to figure out, what did I type, or is it my whole logic that's wrong? What is it that's wrong? Those are the hard ones. So most programmers spend most of their time debugging. And developing good habits is designed to make it easier to debug so you don't waste your time, to be honest with you. And that's difficult to do. So a lot of things I'll suggest, you think, well, that's silly, I can do it a lot quicker. You can do it quicker, that immediate thing, but in the long run, when you go to debugging, it's not quicker. Because you have to include the time from when you first start thinking about the program until you actually got one that gives you the right answer. Errors where code gives you the wrong answer can be errors in typing. A lot of times it's errors of operation, missing operators. That sometimes that'll catch it as an error message, sometimes it won't. Formula derivations, assumptions, things are assumed about the equations that you're not validating, that you're not right. So how do we go about debugging? The syntax ones are kind of easy. The problem is what's going on in the computer's brain you don't necessarily know. You know what you thought you told it to do, but not necessarily exactly what you told it to do. Sometimes it's like having kids. You tell them to do one thing and they interpret your words and do something totally different. So there's the old story about the guy stuck on the desert island and he built a hut and decided to have the monkey as a pet. The monkey would, of course, crap on the floor. And so every time he saw the monkey, he'd catch it, slap it on the butt, throw it out the window. So finally one day he comes up right after the monkey's crapped, and the monkey smacks himself on the butt and jumps out the window. It's not kind of what you wanted it to learn. So there's several tools. The first one, and the one that works 90% of the time, is just echo out. Leave off your semicolon and see what its actually the intermediate values actually are. And that'll catch many of your mistakes. The next one, there are two more formal ways, and one of them for more complicated programs. One of them is called setting breakpoints. And we'll talk about both of those. Let's use a specific example. This is something you might have done in 101. This is out of that book. It's called the Antone equation. It is similar to PV equals nRT, only a different situation. And it tells you what the pressure is as a function of temperature given these different parameters. These are called the constants, and different materials will have different Antoine constants. A and B are units of degree, C is units. And so P comes out in millimeters of mercury. So here's a test case that we run. I had done by hand to check. That's what's supposed to happen. If that's A, that's B, and that's C, and that's your temperature, then you plug it in, make that power, the power of 10, and it should be 11.88 I think it was millimeter of mercury. But here's my equation, or my program, I should say. And I've got this one loaded up. You can download it and look at it if you want to practice debugging. It looks fine, but it has a couple of errors in it. And so I type this in. You can see I'm using a function stored in Anton.m. That's my initial. Notice I didn't use a return. I used an end. That'll work for your main function. I use both down here. Probably been better to use a return. But there's my A, B, and C, my T. There's my call to my function. I don't have it equals anything because I'm going to leave that out and echo it. But my function's called P, A, B, C, and T, using the same variable names in here. And there's where I calculate the power, and then I calculate P. And when I run that, I don't get anything out. Okay, that's all I get. If you run that code the way I've got it up there in Canvas and you bring it down just like what you saw, or type it in, then that's all it does. So what's going on? Well, if you go back and look closely in this one, what you'll find is there's a minor mistake. And this is partly because I didn't make a good choice when I was defining my function. I did capital P, little p, which is okay in some sense, but it makes it a little hard to spot because what I did here is I used a little p, not the capital P. So basically it confused MATLAB. So when it came down here and tried to do P, it says, okay, I know what P is. It gets down here and wait a minute. And then it never returns. It never goes back and finishes up. So all you really need to do is since you've made that a capital P and that a little p, then what you really need to do is make that a capital P. And so if you fix that and run it, still don't get the right answer. It's supposed to be 11.88. So that's not the only problem. One of the difficulties in debugging is sometimes you'll have more than one problem. And so now that made it run further than it did, but it still don't work right, does it? Now, that's a wrong number by orders of magnitude. So let's go look again. And what we can do to help us look at the intermediate values is we can do what we call set breakpoints. That's inside your editor. It's up here. You set your break, go to a line, and it's to set the breakpoint. And then when you run the code, it'll temporarily stop here. And then you can check and see what's going on. So I've set a couple of breakpoints. So it'll come down here, stop. Then I'll tell it to go on. It'll keep on. It'll get down to here. I'll stop while it's down here and see what I can figure out's going on. So I set my breakpoints, and I did a run. And so it came down to here. And then you can go down here. You can either go over here and look at your, or you can come down here and type, see what they are. Now, when you're in the middle of a run, it'll give you a K down here for your run, for your prompt. And so I could interrogate what's A equal to, what's B equal to, what's C equal to. And then I tell it to go on, and I get, and I look, oh, see, here's my values. And I've done this hand calculation, so I know that power should be 1075, but it's turned out to be 158. So there's something wrong with this formula. And remember what have I told it to do? I said go A minus B over T plus, so I'm saying take B divided by T. B, give me a number, subtract it from A, add it to C. And that's not really, if you go back and look at the original formulas, T plus C is supposed to be on the bottom. It's supposed to be A minus B over T plus C. So what's missing? Well, what's missing is I need a set of parentheses around T plus C. So if I do the set of parentheses, like I have it here, and run it, then I get 11.8. Now you've got one that you're going to want to, I've got to debug. I'll have to probably P15. I forgot to look see what number it was. But you've got one that you'll need to debug in a similar fashion. It's got some simple mistakes in it. Shoot me a question shoot me an email if you have any questions.